Hello, my name is Jonathan Wine. I am the project leader for Western Michigan University's Advanced Rocketry Club. Our club leadership structure is shown here. As the team leader, I oversee operations with both payload and launch vehicle teams. Our launch vehicle leader this year is Matthew Martin. He is responsible for flight simulation, launch planning, the recovery system of the rocket, as well as construction. Our payload team leader this year is Grace Klang. She is in charge of the payload structure, payload ejection, electronics, payload recovery, and both team leaders work together on system integration. Our faculty advisor is Dr. Christina Lemmer. Matt and Grace will now tell you about their subsystems.
Hello there, I'm Matt, and I'm this year's launch vehicle lead for Western Michigan's 2022 to 2023 AIAA organization. Below is a list of my members. This year we went with a 4-inch Broken Arrow XL design. The top half contains our payload, which will be ejected from the top of the avionics bay using black powder charging. In the bottom half of the rocket, we have a double parachute system, which we will deploy at apogee and a set altitude for the main chute. This will also use black powder charging. The stability of this year's rocket is about 2.75 calibers with a total length of 90 inches. Below that is a photo of our rocket, which still needs to be completed with a paint job. This slide highlights the construction of our rocket. On the left, you can see that our team is epoxying our fins with reinforcing carbon shards, and then on the right is our eBay configuration featuring a switch and 2 blast caps made out of PVC piping. From the rocket geometry shown in the previous slides, here's our open rocket simulation. Apogee is achieved close to 12,000 feet, which is well within the competition rules. The first deployment will occur at this point, followed by a second parachute deployment closer to the ground. Displayed here is the thrust curve for our motor, an L2200G, which has a 14-second delay.
Hello, my name is Grace Klang, the payload lead, and I will be explaining Western Michigan University's ARC payload design for the 2022 to 2023 year. But first, let's introduce the wonderful folks helping make our goals possible. Evan Schubert, Sam Usher, Yesenia Fuentes, Carter Simmons, Derek Martindale, and Jenna Warman. Last but not least, our meetings and progress are aided by our rocketry lead, Jonathan Wine, who also oversees our sister launch vehicle team. Now, the moment you've been waiting for, our design. The photo in the bottom middle, here, is the frame of our drone design. The bone drone, given its femur-like shape, was a design we agreed upon as a team both for its efficiency in flight as well as its effective use of space. The yellow parts shown here indicate the space claim available by my team in the launch vehicle, as shown from the rocket side and opening slots. As you will see, the length and narrowness of the design lends itself well to the shape of our launch vehicle and leaves us ample space. On this next slide, we highlight the bare bones of our design. Beginning with the actual drone body, you can see how its elevation saves us space in the narrowness of the tube. Above, we put our flight controller, speed controller, and GPS. Whereas to the sides, we have our motors here in blue and our folding propellers here in pink. Below, we have the battery and golf ball. And we even left ourselves extra room for miscellaneous things such as our explosion cap and insulating material like dog barf. Here's our parts list. For the motors, we will be using the iFlight Crossing 2. Our props are the Dell Prop Fold 5.1-inch folding propellers. Our speed controller is the SkyStars 4-in-1 36S 30x30 speed controller. Our battery is the Ovionic LiPo battery. Our flight controller is the Maytech F405 WTE flight controller. And our GPS is the Geek Story BN880 GPS module. That is all I have prepared. Thank you for your time, and my team and I can't wait to see you in Kansas.